So we are welcome to our weekly machine learning section. So today we are going to be taking us through what we call the comprehensive machine learning watch list guide and recommendations for our weekly videos that have been uploaded to our YouTube channel. We had to do this having noticed several of our new members that have joined. And since it is practically impossible to start from the beginning whenever we have new members. And we thank God that the idea came very early in the life of these weekly lectures, that we were recording the videos, and then suggestion came that we should also be uploading it in a YouTube channel. So with this, I want to believe this is going to make it easier for people that have just joined to catch up. So we are going to discuss this at the beginning of this session, and then we are going to give room for question and answer or any issue that anyone is facing in our various personal effort to practice some of the concepts we've learned. So machine learning is a concept that can no more be ignored by anyone, be you in private sector, academics, just to mention any field you are. So we can no more ignore machine learning considering what AI is doing and capability of the AI. However, going into a YouTube channel, so to the glory of Almighty Allah, so we'll be able to upload at least 137 videos. So if a newcomer just see 137 videos, it could be very confusing. Where do I start from? So this is why we have taken this pain to prepare a comprehensive watch list guide that can guide us where we should start. And got so good that the videos were made very simple and easy to follow. So with those guides, you look at what is appropriate to your level. Then you try to watch out some of these videos. Then while watching it, you can then pen down anything that is not clear to you, which you can be clarifying during our weekly question and answer sessions. And you are also free to also contact the team and especially contact me if you need quick clarification to whatever you are doing presently. We have been getting such contact on regular basis. People running experiment, they run into trouble, so they don't want to wait next week session. So you're always free to contact, send us whatever messages you have. So, and we try as much as possible to guide through. So I want to believe this watch list guide is a must for every member of the team. And we also encourage us to kindly share the link. I mean, tell people about this kind of opportunity. So our aim and objective is to benefit people as much as possible. So a couple of people contacted me recently, and they expressed their dismay or their surprise that this kind of thing has been going on for long, that they were never aware of it. Some of them were master student, PhD student, and so I cannot contact everybody. So even some people I actually knew, so I thought they were aware, so they were not aware of it. So I kindly implore us to let us share it and then broadcast, let people be aware. Perhaps your effort might benefit somebody at a very early stage. So like I said, it's very easier to follow whatever we have been doing. So if you are new, don't worry, you are going to catch up. So we'll be going through this guide. And I want to also believe in some of the people that have been with us for long, they will benefit a lot from the watch list guide that has been prepared, because it involves going through each and every video that has been uploaded, 137 of them, and then trying to group them to where we think they are appropriate. So, of course, you have the contacts, so you can always contact, or you can also send a WhatsApp message. So the essence of the channel guide is to facilitate maximizing the benefit from the uploaded videos, so that you can easily catch up with whatever we are going to be discussing as we move forward. So the first watch list that is highly recommended for every member, especially the new members, is the one we call the introduction. So this playlist contains general introduction towards understanding machine learning fundamentals, what it is and how it works. So we call it live revision playlist. It was a set of revision classes or sessions where we had maybe of 4 or more videos in this respect. So these are the videos featured under this machine learning live revision. You have the part 1 of the revision. I started from the basic of machine learning. What is machine learning? How can we benefit from it? And also for that. So I want to believe by the time you finish 1, 2 of that, so you should be on a very, very good note to be able to follow us appropriately. So you have the part 1 to part 4. Then we have evaluating machine learning models. So how do you evaluate? When you build model, how do you evaluate it? We also have 4 parts in that particular series. So once you are done with this and you are comfortable, then you can move on to the second playlist, because which is the playlist where we said machine learning with Weka. One of the essence of this session and my approach is to teaching machine learning is the belief that showing people the reality that you get it to know that it's good to have programming knowledge. However, not having programming knowledge should not prevent you from using machine learning and AI. So this is a basis for which we are actually using Weka, which is a very easy to use package. So it contains several machine learning algorithms that we can select from, and then we can be able to build our own model after listening to those few introductory videos, maybe 1 to 3. 1, 2, 3. By the time you are done with part 1, part 2, part 3, you should be able to move to this playlist where you can now practicalize in Weka, build your own first machine learning model, and it is easier. So you have the first one, introduction to the Weka environment, running your first machine learning experiment in Weka. So working with Excel, CSV file, and the .arff file in Weka. The original file that Weka usually uses is this. However, creating data set using it might be a little bit challenging for starter. So you can put your file in Excel and then save as CSV. Once you load it to Weka, then you can then save it to .arff if you wish. It's not compulsory. You can continue to use your file as CSV because the CSV is easily created as it is just like normal Excel file. Then after that also we have another video discussing 20 hyperparameters of machine learning algorithm in Weka. So with the case study on k-nearest neighbor. K-nearest neighbor is one of the very simple algorithms that works on the principle of tell me your friend, I tell you the kind of person you are. So we look at people that are closer to you in attributes. So based on those things, we select 3 of them. If K is equal to 3, we select like 3 of your closest sample based on the attribute. If out of those 3, if 2 of them belongs to a group A and the third person belongs to group B, so majority carries the vote, it means you are going to also belong to group A. Because among the 3 people that are closest to you, so 2 of them belong to A, so definitely we can conclude that you belong to A. This is what the summary of k-nearest neighbor. We have a video on that later on. So how do we tune the hyperparameters? Because once you have built a model, so the default parameter might not give you the best result you are actually looking up to. So what you have to do is you need to tune the parameter. You have to change the values. For example, k is equal to 1 is the default. With your nearest neighbor being 1, maybe you didn't get the best result. You try 3 if it is classification problem. You try the odd numbers, especially if you are dealing with binary classification. You try the odd numbers, 3, 5, 7, so that during the voting process, you don't run into tie. Because if you choose 4 for a binary classification problem, class A has 2, class B has 2. So there's no way you can decide where to push the current sample to. So this is called tuning the hyperparameters. So there are other videos that will support in that area. So then still under the Weka playlist, how to implement different partition method for model building in Weka. So when you want to build, once you listen to the first 3 videos on the introduction above, then you understand the principle of, okay, how do we evaluate machine learning model? Then how do we demonstrate it in Weka? So you have to divide your data into training set and testing set for supervised learning. So during the training, this is when the machine learning try to understand your data set and build a model that you can use later on same data set. So how do you partition the data? So using direct partitioning, the one we call the holdout method, or you want to use the other methods whereby you have to partition it repeatedly into maybe 10 folds or 5 folds, or as the case may be. So this is taken care of by this video, how to implement different data partitioning method for building machine learning models in Weka. So we also have question and answer section that follows that video. So after the video, after the section, people ask questions. They're also there to clarify whatever was not clear. So, and this is our norm in every session we have. So if you have any question now, you can note down your questions. Once we are done with the first session, then the second session, so then you can ask whatever is not clear. So still under the Weka, we call this Hello World from Machine Learning Model playlist. This is under the Weka playlist. So after you might have watched the introductory videos, this is like a kind of welcoming you to the world of Weka, how to practically demonstrate the concept you have learned. So we have 1, 2, 3. Actually, we have 3 videos with their questions and answer section in this particular. This is to actually reinforce. That's why I call it 2B. So it's like still clearly under this playlist. So it reinforces whatever you've learned from this. So, and you have that liberty to either start with this. It's better for you to start with this, at least introduction to Weka environment. Then you have that liberty to look at the Hello World machine learning while checking out some of these videos to guide you on how to implement your first set of models in Weka. Then 2C, here we say moving forward with machine learning based project, a quick glimpse into machine learning experiment in Weka. This is another video again, still following the path of demonstrating how to build machine learning model in Weka environment. So we have another video here with the question and answer. So with that, this is going to give you a lot of demonstrations on how building basic machine learning models works. Then we also have 2D. So this is practical demonstration of machine learning modeling using Kaggle dataset. In these sets of videos, what we just did, we make use of the very popular dataset source, or you can call it data science competition-based source. Kaggle is a very popular website where you have a lot of data sets. So we pick a couple of data sets from the Weka from there, and then we demonstrated how to build a model from the scratch. That's why we call it practical demonstration. That is from Kaggle dataset to building ML models in Weka, part 1. So here we pick a particular data set, and then we were able to demonstrate how to pick the data, look at the data, process it if necessary, and then run your model successfully. Again, we have the part 2 for several sections. We have part 2 for that one, the one part 2. So, and then there are kind of series up to day 2. part 1, then day 2, part 2, until the end. There are a series of videos in this respect. So here you can see here we demonstrated customer churn prediction. So it's an example. So you can pick any of the example that suits you. You don't need to watch everything before you understand it. Pick which of the one you feel you are interested in. For example, people who are interested in customer churn prediction. So you can check out this video and then the question and answer and see what demonstration of how you can build your own model has been presented. So that is on that. Now, moving further, number 3, watch list 3, we call it a tour of selected classifiers or algorithms. So we selected a couple of classifiers that, okay, we have seen how to build model. You just need to click, select those classifier in Weka environment, upload your data set, click run, and you completed your model. However, we want people to have a glimpse of what is really happening inside that algorithm. So what is that algorithm? What is unique? Why is it that you just give a data set and then you select an algorithm, then it will build a model, an hypothesis function that you can use to predict unseen situation, unseen data set, or new set of data set that will come later on. So we now say, okay, it's good for people to have a little bit of what is going on inside this algorithm. So as a starter, it's not compulsory, but it's good. At least you have little knowledge of how this algorithm, especially the simple one, how it works. So we had a selected tour, a few of them. So we started with we've started with categorizing, discussing generally classifier in part 1 and part 2. What are classifier? What are the different types of algorithm? Is it distance-based algorithm? Is it algorithm based on error calculation? And host of other. So the first algorithm we discussed was k-nearest neighbor, the one I just mentioned not long ago. It's a very simple and interesting algorithm. It works similar to the principle of tell me your friend, I will tell you the kind of person you are. It means the people that are closest to you in terms of attributes, you are likely going to exhibit their own character also. So it's a very simple algorithm that is often used to check when you have a new data set. So it's always good to check it. And the one unique principle with machine learning, which you will learn when you listen to the introductory videos, is that it depends on the data set. You cannot determine which algorithm is going to be better for a particular data. So you have to check. And one of the principles of checking is to start simple. You start from very simple algorithms. Don't jump to deep learning. Don't jump to support vector machine. These are complicated or sophisticated algorithms. Because sometimes those sophisticated algorithms might not work for your data. We have seen cases where people went for deep learning. At the end of the day, they find out that KNN actually will perform better than what we were able to get. Because it's a matter of let the data speak. We're going to have other videos on that. Let the data speak. So you have to check. And the principle of checking is to start simple. Start from simple algorithm, try KNN, try decision tree, try naive Bayes, and then you can keep moving gradually to neural networks, support vector machine, and most of other algorithms. So here we describe KNN. We also describe decision tree. So then naive Bayes, this is probability-based machine learning algorithm. So, and then we ended that section by making demo on the three of them, KNN, decision tree, and naive Bayes. We ran a demo in Weka of how to use the three of them. So having listened to the theoretical basis of each of them, then you can enjoy the demo, how they work. After that, still on selected machine learning algorithm, another very popular algorithm is support vector machine, very powerful. So it often gives very, very unique results in several cases, but not in all cases. Because there's no algorithm that you cannot guarantee that it's going to work in all situations. But it has distinguished itself as one of the very unique algorithms to always look out for. Once you use the simple ones that are not working, it's a good candidate to look after. Hopefully you can get something better. So we have series of part 1, part 2 on the fundamentals principle of support vector machine. And then we came back later, another time, we had another special series on support vector machine. We call it important facts and points to note about support vector machine. Because of the unique nature of this algorithm, so we came back, we had a series of sections again, where we are clarifying some of the important facts and features to note about support vector machine. So we have another part 1, the question and answer, part 2, question and answer, part 3, part 4, part 5. So, and then even up to part 6, like I said, it's very unique algorithm, and several projects has been used with success, very, very encouraging and unique capability and unique outcome. So, however, that doesn't mean it's going to work in all situations. The principle of let the data speak is always the best thing to follow. So that is on the playlist on selected algorithm. So yeah, the fourth one is what we call the Researcher's Corner playlist. Researcher's Corner playlist. So as some of our members at the beginning were actually researchers, so we discussed a lot of stuff on how to carry out research using machine learning. So these days, a lot of research institutions, the research institute, universities, they even put condition on some of their project funding that it has to contain some element of artificial intelligence or machine learning specifically. So we feel that then it is necessary for us to also guide our people on how do we use machine learning to carry out research. Irrespective of your field, you can take a huge benefit, especially now the journal houses are promoting or expecting interdisciplinary, even multidisciplinary research. It used to be interdisciplinary, that is between two departments. But now they are talking of multi, bring idea from several departments or several fields, let them match together and get us good research outcome. Because by doing so, smart journal houses want researches that cut across several departments so that citation will increase faster. Because if you have a paper published that cut across computer, maybe geology, and then another field, material science, it means people from all these fields, they will have to compete in checking out the research outcome and mostly using it, benefiting from it, and then citing them appropriately. So this is why multidisciplinary research is becoming very popular, especially with the use of artificial intelligence and machine learning. So here we had several videos in this series. We call it Researcher's Corner playlist. So we can check it out, those of us who are interested in research, featuring the following video titles. We have doing research with ML, machine learning, part 1. How do we do research with machine learning? We have in series part 1 up to part 4. This is going to be an eye opener for us, especially those that are new. How can I use machine learning to do research? You have more than enough to check out there. We also prepare a special template, which is a Microsoft Word document, MS Word document, a special template on how to write your report. How do you write research paper based on machine learning? So in this case, we had a video on that particular template, and the template has been provided in our WhatsApp group and Telegram group. We can check it out and also encourage our team members, our management team, to also please help us repost those documents so that people can take it. It starts from writing abstract, writing introduction, up to the end of a full research paper that made use of machine learning. So part 1, especially here, it's more talked about how to write your abstract. Part 2, abstract, introduction, how to write the experimental description, up to the conclusion. So this will definitely provide a guide for those people that are interested in using machine learning for research. As I've stated, once you watch them, note down whatever question or whatever is not clear. We're always available, and we are still going to come back later, hopefully, to discuss based on matter arising or question that people may have. So on the template also, this video is specifically dedicated to that template, describe it in details. So, and the template is for free. Anybody, you are free to use it in your own research work. So still on the Researchers Corner playlist, we have another one called Towards Research Collaboration Guide. We made a video on how to make research collaboration. So a simple guide, hopefully it will also be interesting to the research community. Yeah, and we also discussed another one, how to make, that is, how to make towards establishment of viable machine learning-based research collaborative groups. Yeah, so this is the question and answer. In our team, if you are in the WhatsApp group, we have several research groups already. So some of the groups are already very active, working on research papers. So we also we request the management team to kindly help us share the link to join those teams. For those that just joined on recently, you have opportunity to join any of those research teams. You see the coordinator there, a lot of people in that team. You click the link. Once you join, you see discussion. Sometimes they come up with a paper and they request for who want to participate in this paper. If you are interested, you join them and then they provide the necessary guide on how you can collaborate and get your research work completed based on the machine learning usage, and then you work towards the publication. So, of course, this is totally optional for those that are research inclined. So, moving forward with machine learning-based research, a simple gap identification guide. Gap identification guide. We made a video also in the past. This is, you can find it here. The idea is that how do we identify research gap from machine learning-based research point of view? So it was a very interesting section there, and I remember. So we can benefit ourselves by looking into that. How to, because sometimes you see something has been done. The fact that someone already worked on that project doesn't mean you cannot work on it again. There are several gaps that are always available in machine learning, from machine learning point of view. So we describe extensively in that video how to identify gaps or research gaps in the area you are trying to focus on, even if it has been done before. Is it from feature selection point of view? Is it trying to see the kind of algorithm they have used? Have they achieved what they're looking for? Can we make it light? You see, can we make it light? Somebody used like 50 features to build a medical application. Can I use only 5 features to build the same application? Is it possible? So all these possibilities are also further. They were well presented in this particular video, so we can check them out. So this is the question and answer on that. Again, moving forward with machine learning based research project, a quick glimpse into machine learning experiment in Weka. Yeah, we described this one also. So this video can benefit both the starting point and here it benefits the researcher most. So if you want to do research using machine learning, then this is a demonstration of how you can actually do that using Weka. We have a video there and a question and answer section. So those are the 4 playlists that I believe we can cover for the day. So inshallah, by next week, we're going to continue with real-life application of machine learning. That here we look into summary of past successful application of AI and machine learning applications as a way of kind of motivating us to see what we can do, what is possible, and what are the boundaries you can actually extend and try to make things better. So this we are going to consider hopefully next time. So we're going to stop at this point for the day. Thank you very much for listening. If we have anybody have a question, we're going to move to question and answer section for the day. Once again, thank you very much for listening, and then I wish you all the best.